Ever pondered the science behind those high-resolution aerial images that map out forests, roads, or streams? The answer lies in a fascinating process called aerial photogrammetry. Aerial photogrammetry, a subset of remote sensing, primarily utilizes visible light waves from the electromagnetic spectrum, though it also finds utility in near-infrared applications. It is the method of choice when creating geographic databases in forestry and natural resource management. The process starts with the capture of vertical aerial photographs. These are images where the axis of the camera deviates no more than 3 degrees from the vertical. Often it involves the use of stereo pairs, which are overlapping photos. However, reasonable measurements can also be made from single vertical aerial photographs, provided the scale of the photo is known. After the capture, the photographs are interpreted, a task that calls for a keen understanding of geometry, trigonometry, optics, and natural resources. This interpretation allows us to identify and estimate the size, length, or height of objects on the ground. The interpreted information is then extracted from the photographs using stereo compilers. These ingenious tools correct a significant portion of the errors emanating from sources of distortion and displacement. Alternatively, the interpreted details can be transferred to maps using hand-drawing processes or traditional digitizing processes. This process doesn't stop there. Information about the camera and terrain is combined in an analytical model. This model computes the coordinates of features using soft copy photogrammetry techniques, which are personal computer-based. But the pièce de résistance of aerial photogrammetry is the geo-referenced digital orthophotograph. To create an orthophotograph, vertical aerial photographs are first scanned using high spatial resolution scanners, or images are acquired from digital aerial photo cameras. Then, the topographic displacement and other distortions are analytically removed from the photographs. The photographs may be combined and are then geo-referenced to allow their accurate placement on the landscape. Orthophotographs can exist in hard copy versions, commonly printed on mylar maps or glass plates. The digital orthophotographs, on the other hand, are soft copy versions that can be used in conjunction with computer software. To recap, aerial photogrammetry is a multi-step process that starts with the capture of vertical aerial photographs, involves interpretation and extraction of information, and culminates in the creation of geo-referenced digital orthophotographs. It's a blend of geometry, trigonometry, optics, and natural resources, aided by the use of stereo compilers and analytical models. The result? High-resolution aerial images that prove invaluable in forestry and natural resource management. Aerial photogrammetry, a process that's as fascinating as the high-resolution images it produces. It's more than just a snapshot from the sky. It's a blend of science, technology, and a keen understanding of our natural world.